So, nomenclature. Describe what they are, and then we learn how to name them. The smaller alcohols, the first, with 1 to 4 carbons, these have common names, and the common names are used frequently, and so we do need to know them. Naming these with a common name, you name all of the carbon atoms of the molecule as a single alkyl group, and then you add the word alcohol, and the words are separated with a space. So this is looking at it more as an alkyl substituted water molecule. So here's methyl alcohol. So this is a methyl group, and the OH is alcohol. Ethyl alcohol. So we're naming the alkyl group. This is ethyl. There's propyl alcohol. So there's the propyl group. Over here, if we put the OH on that middle carbon, this is the isopropyl group. So that's isopropyl alcohol. And here we could name this guy as cyclobutyl alcohol. So that's the common method of naming, and those are used for the smaller alcohols. IUPAC rules, again, we're just building on what we've already learned. We're going to name the longest carbon chain. Now here, the hydroxyl group has to be attached to the longest chain. It could happen that there's a longest chain that doesn't include the hydroxyl group, but you have to include the hydroxyl group. We take, from the length of that chain, we get an alkane name. We drop the E and put in OL. Then we're going to number the chain starting at the end nearest the hydroxyl group. And so this is like we did with the alkenes and the alkynes. You start so the functional group gets the lowest number. And the new ones, we're studying these basically in the order of low priority to high priority. So as we learn a new one, the new one takes precedence over the older ones. So the hydroxyl group is more important than double and triple bonds. So we focus on the hydroxyl group if it's present, and so that we name it as an alcohol instead of as an alkene or an alkyne. Then you name and locate any other substituents present. If you have an alcohol group on a carbon ring, like with other functional groups, we're going to start numbering with the carbon that the OH is attached to. Then you'll go clockwise or counterclockwise to get the lowest numbers for the other substituents. And again, we tend to eliminate the number 1, so we're not going to use 1 hexanol, cyclohexanol, because we assume that we're starting with 1 for the hydroxyl group. So let's look at some examples here. So for the 1 carbon atom, there are no isomers. So the IUPAC name is methanol. Because we look at the carbon chain, it's 1, that would be methane. We change the E to all, we get methanol. The common name is methyl alcohol. 2 carbons, this 2 carbon chain is ethane. So we change the ending to all ethanol. And we've already looked at these common names. This one is 1 propanol. So we've got the OH on the end. Here, the hydroxyl group is attached to the 2nd carbon in the chain. Here's the longest carbon chain. It's 3 carbons. And so it's 2 propanol because we're indicating where the hydroxyl group is. We don't need to do that for ethanol and methanol because there's only one possibility. 4 carbon atoms, as we get a higher number of carbon atoms, we get more isomers. So here's a straight chain. That's 1 butanol with the alcohol on the end. We can also have 2 butanol. That doesn't look like a straight chain, but it is. The carbons are just in a row. The difference is the hydroxyl group is on the 2nd carbon. Here we have a branched chain. So we're going to count these 3 carbons here as the longest chain. So that's propanol. The hydroxyl group is on the first carbon, so it's 1-propanol, and then on that second carbon we've got a methyl group. So 2-methyl, 1-propanol. And these guys also have common names. That would be isobutyl alcohol. And then on this guy, we have the alcohol again on the second. So this one had, you know, it's hard to see patterns in these sometimes. You kind of have to look around. As we can see, this is oh, I changed. Yeah, there we go. Straight chain with the alcohol on the end. Straight chain with the alcohol second. Here we've got a branched chain with an alcohol on one of the ends. And here we have that same branched chain, but now the alcohol is on the center carbon instead of one of the ends. But we've got 3 carbons, no matter how we count it, so that's 2-propanol with the methyl group also on the second carbon. See how that works, kind of? So let's practice a little bit. Name the following alcohols utilizing IUPAC nomenclature rules. So not the common names, but the IUPAC. So the first one, letter A. First we have to figure out the longest carbon chain that includes the hydroxyl group. So we could count here 1, 2, 3, 4, 5, 6. No matter how we count it, we're going to end up with 6. So that's going to be hexanol, because the longest chain would be hexane, and the hydroxyl group makes it an alcohol. Then we have to decide how to number this. We could number 1, 2, 3, 4, 5, 6. And that would get us a 3 for the hexanol. We've got a couple of methyl groups on here. And we'd get 2 and 5 for the methyl. 2 and 5 for the methyl, 3 for the hexanol. So let's see what would happen if we numbered a different way. What if we started at the other end? 1, 2, 3, 4, 5, 6. Well, now the alcohol is number 4. The alcohol is the most important, and so we're going to choose based on that, and so we're going to choose the red one. So this will be 3 hexanol. The 3 tells us the hydroxyl group is on the third carbon. And then we have 2 methyl groups, so that's dimethyl. And then in front of that, we list where they are. Well, they're on the second and the 5th carbon. So we kind of end up putting these names together backwards. So naming these guys often involves some scribbling. Any questions? I'm going to check myself because last week I got one wrong. It's not good. These are the practice exercises from the textbook. 2,5-dimethyl 3-hexanol. Yep, that's what I came up with too. And what's the base name for letter B? Is it hexanol? The longest chain I can find would be along here. 1, 2, 3, 4, 5. So that would be pentanol. So pentanol. And where would we want to start numbering? Would we want to start on this end or the other end? want to start here, right? Because that's where the hydroxyl group is. So 1, 2, 3, 4, 5. So that's 1 pentanol. We've got a substituent on here, a methyl group, and that's on the 3rd carbon. So 3 methyl, 1 pentanol. Remember, numbers are separated from each other by a comma. Numbers and letters are separated with a dash. Any questions? Couple more. Letter C. And we're always looking for the parent. And with IUPAC nomenclature, that's generally the larger part. So what's the largest part here? Well, it's this ring, isn't it? And that ring has how many carbons? It's got 5. So that means it's cyclopentane. With the hydroxyl group on it, it becomes cyclopentanol. Cyclopentanol. The hydroxyl group is attached to the ring. We have to start numbering the ring where the hydroxyl group is attached. And then we can go clockwise or counterclockwise. Well, what groups do we have here? These look like lines, but those are methyl groups, aren't they? So if we go clockwise, we'll end up with 1 and 2. If we go counterclockwise, we're going to end up with 1 and 5. So we're going to choose the one with the lowest numbers. So we'll have 1, 2 dimethyl cyclopentanol. 1, 2 dimethyl cyclopentanol. I don't need a 1 for the ol. I don't need to say 1 cyclopentanol because we will always start numbering from the hydroxyl group, the alcohol. How about this guy?
And with the alcohols, will you ever have more than 1 hydroxide?
Yes, you can have more than 1 hydroxyl group. We'll talk about that in a minute. Letter D, what's the longest chain? 8. Okay, so that's octanol. Can you see how spelling gets important here? Enes and anes and ines, and it's just, some of them are just one letter different. It's a very different chemical. This is octanol, and let's see, 1, 2, 3, 4, 1, 2, 3, 4, 5. So we want to start numbering from this end because it's closest to the hydroxyl group. Because the hydroxyl group is most important. We focus on him, and then we look at other things. So that's 4 octanol. And here's another little methyl group. So that's on the 5, and so that's 5 methyl, 4 octanol. Sometimes the rules seem a little complicated, and I guess in a way they are, but the nice thing about them is that they're consistent, and there's a pattern to them. We're going for lowest numbers. We're going for alphabetical order after that. We have a specific order in which we look at them. We don't have to debate, well, should we name it as an alkene or should we name it as an alcohol? Alcohol's more important. And you just have to play the game until the rules become familiar. You can't just start out playing Dungeons and Dragons having read through the rule book real quick once. You're going to screw up a lot. Or poker, or any game. you have to play a little while. You make mistakes, you correct, and then after a while, you start to understand it a little better. Any questions about naming these alcohols? So we can have more than one hydroxyl group on an alcohol. And to do these, we just have a slight modification of the rules. So an alcohol with 2 hydroxyl groups is called a diol. So we put a little prefix in before the suffix. You like that? So there's diols and triols. So this one, oops, didn't mean to do that. This guy down here is ethane diol because there's 2 alcohols. And the numbers up here tell us where they are. So this is a simple one, it's only 2 carbons, and this is telling us that those hydroxyl groups are on different carbons. So it's 1,2 ethane diol. And this next one has 3 carbons, so it's propane. And the E here on ethane is left in there just to make it easier to pronounce. So instead of ethanediol, it's ethane diol. So that one's propane diol, and the hydroxyl groups are on 1 and 2. Now they could be on 1 and 3 also. And then this one is a triol. 1, 2, 3, propane triol. And these guys do have common names as well. Yay, right? This one is called ethylene glycol. And this is propylene glycol. And this guy is glycerol. And we'll talk about those. And glycerol. Those are their common names. We'll talk about those guys a little bit more later in this chapter.